So I'm calling this note 6.4 and beyond, and this is where we really get good at solving systems but deciding which method to use. This is when you're solving systems of equations, you have three methods you could choose to apply. The first one we learned was graphing. The second one was substitution, and the third option is elimination method, also known as linear combinations method. It says, I recommend using elimination method unless your system has both equations in y equals mx plus b form. Then I would think of their graphs. Then I would go with graphing. So what I'm saying is, when you look at your system, if you see that they're ready to graph, y equals m, this is your slope, rise over run, x plus b, and this one's also on y equals mx plus b, then think of their graphs. It'll be a lot easier. I mean, you could change this equation and rewrite it in standard form, and you could use elimination method, but that's going to be a lot of work. If you realize that they're ready to graph, why not think of their graphs? So let me do this. Let me actually draw a XY plane. And if we take a look at the above equation here, we know that the b value is 2, and that means that it's going to cross the y-axis at 2. And then from that point, I'm going to go rise and run. So I'm going to go up 2 over 3. So if I do go up 2 over 3, I'm going to end up at this point over here. Should do it in red. And then I draw my line, and that is the graph of that line. I mean, a sketch of it at least. Now the bottom one, as you could see, it also has the b value of 2. So this bottom one I'm going to draw in blue. It also crosses at 2, but this one has the slope negative 5 over 3, which means you're going to go down 1, 2, 3, 4, 5 over 1, 2, 3, and put a dot right here, which is going to give you that graph right there. I mean, a rough sketch of it. But the bottom line is, we know the red line represents all the answers to the top equation. The blue line represents all the answers to the bottom equation. And if you want the answer to the system that works for both, obviously we're looking for that point that's in common. And what is the location? That is the location 0 on the x, 2 on the y. So without doing any math, I could clearly see that my answer is 0, 2. So I would not use the elimination method here. I would not use substitution method here. I would think of graphing. Of course, if you're not too sure about your answer, you could always double check, plug in your x right there, plug in your y over here, and then see if it gives you a true statement on both equations. That's how to double check. But my point here is, if your equations are ready to graph, like right here, they're ready to graph. Why not graph them, or at least think of their graphs? So I don't even need to graph, because I know that this slope, 2 over 3, is the same as this slope, 2 over 3, which means that they have the same steepness, which means that they have the same slope, which means that they have the same direction, which means that they're parallel, which means that they're never going to cross, right? They're parallel. So, I mean, even if I graphed it, the top equation in blue crosses at 5, 1, 2, 3, 4, 5, right here. It goes up 2 over 3, up 2 over 3, put a dot right there. There's your line. If you graph the bottom one in red, it crosses at 2, right there. It goes up 2 over 3. And as you can see, they're parallel. So you're looking for the point of intersection. You know they're not going to cross. So you don't have to do any math. All you got to do is recognize that the same slope means they're parallel, which means that they don't cross, which means that the answer is that there is no answer, no solution. And of course, you could also do this symbol as the answer. Now let's move on. Down here, it says, or if you had an equation that already had an equation, that kind of sounds weird, sorry about that, with the variable isolated, then substitution would be good. Okay, so my point is, it's always good to use elimination method. That's the fastest, best method. But if they're ready to graph, you might as well graph. Or if they're ready to substitute, you might as well substitute. So how do you know when they're ready to use substitution? It says that it has a variable isolated. That means it has y by itself. So when y is by itself, you might as well take that variable expression and plug it into the equation that you have not used into the y. Now once again, if this were an x, you'd be plugging into x, but it says y equals, so we're plugging into y. So we're going to rewrite this thing, and again, you need to show your work on your quiz, on your test, or else you don't get credit. So rewriting this thing, we're going to have a new equation over here on the side. It's going to say 3x plus y. Now, instead of me writing down a y, I'm going to plug in the negative x minus 2, and then equals 12. Equals 12. Now notice that it's always a good idea to put it in parentheses, but there's nothing to distribute. There's no number out here. There's not even a negative sign. There's a plus sign, and if you distribute the plus sign, nothing happens. So you could just rewrite the whole equation without parentheses. And then after that, you're going to solve, obviously, by doing combining like terms. We already said there was no distributive property, so let's combine 3x, take away x. 3x take away x is 2x. Bring down the rest. Minus 2 equals 12. And of course, we're going to solve this thing by getting rid of that minus 2 first by doing plus 2 and plus 2. So we're going to have 2x equals 14, which means when we divide by 2 here, x equals 7. That's one answer. And of course, we need the other answer. So we have 7 for x. We still need the y. And all you have to do there is plug in your x value of 7 into any x position, either here or up here. It's totally up to you. I would pick this one because it says y equals, all you got to do is put that 7 right in there. So let me write it out again. Notice that I wrote y equals negative blank spot, or negative parentheses minus 2. There it is, y equals negative x minus 2. I'm going to take the 7, put it right in there. So that's really just a negative 7 minus 2. So if you think about what is negative 7 minus 2, that's simply y equals negative 9. You owe $7, you owe $2, you're going to owe 9 altogether. So my final answer that you should write on your answer spot, on the answer column, is going to be 7 comma negative 9. So that was another example where we did not use elimination method. Okay? But for the most part, I would recommend using elimination method, always, if you can. When it's set up, that is, which we've been practicing on sections 6.3 and 6.4. So right here, x is on top of x's, y is on top of y's, equal on top of equal, number on top of number. This is ready to do elimination method. This is not ready for graphing. This is not ready for substitution. So this is why we're going to go with elimination method. Now remember, the goal of elimination method is to get either the x's to eliminate or the y's to eliminate. And there's many roads to the same place. So you always want to pick the quicker path, the one that's most direct to your answer. So you got to think, if you wanted to cancel out the x's, all you have to do, this is a positive 2x, all you need to do is change this 2x to a negative 2x, because 2x and negative 2x will cancel out. So that's really simple. All you have to do is multiply the bottom equation by negative 1. Now, let's say you didn't want to cancel out x's. Let's say you wanted to cancel out y's. That would require more work. I mean, you could do it. Like I said, there's many roads to the same place. But you'd have to change this to a positive 10y by multiplying the whole thing by 2. And you'd have to change this to a negative 10y by multiplying the whole thing by negative 5. So why would you want to do more work? I mean, unless you're bored on a Saturday night, right? Then you could do that. But this is the quicker path, and you want to use the quicker path, especially on Friday's test. There's a lot of questions. It's timed. So let's go with the quicker path of eliminating the x's. Let's multiply everything on the bottom by negative 1, and we're going to get the new equation. Negative 1 times 2x is negative 2x. Negative 1 times positive 2y is negative 2y. Negative 1 times 6 is negative 6. All I did was distributed the negative 1 to each and every term. It has to be to all terms on the equation. Now the top equation, we're not going to do anything to it. We're just going to rewrite it. And then from there, now it's ready to combine the lines. That's why it's called linear combinations. So when we combine the lines, the x's really do eliminate. The 5 minus 2 becomes positive 3, and of course we have a y. The equal sign comes down, and negative 3 and negative 6, if you owe $3 and you owe $6, you're going to owe a total of $9. So this blue equation here is a simple one-step equation that we could all easily solve. And all we have to do is divide by 3, and we're going to get the first answer, y equals negative 3. Okay, doesn't matter if you get x first or y first, that's one answer. You still need to find the other. Keep in mind, on your answer column, you want a coordinate, x and y. So far we have the negative 3. Let's find the x. Once you have either x or y and you want the other letter, all you have to do is plug it into any original equation and solve. So I'm going to plug it into the bottom equation, 2x plus 2y equals 6. So as you could see, I rewrote it. All I'm going to do now is plug in the y value. See how y is now a parenthesis? I'm going to plug in the y value of negative 3 right in there. And of course, now I'm going to do the math. I want to solve. So 2 times negative 3, that's negative 6. So I really have 2x minus 6 equals 6. Now from that point, I'm going to get rid of the minus 6 by adding 6 and adding 6. My new equation will read 2x equals 12. And my final step will be to divide by 2 on both sides, which means that x equals 6. So my answer is negative, or actually not negative 6, I'm sorry, 6 comma negative 3. That is my answer to the system. So most of the time we will be using elimination method unless it's ready to substitute like this one was, or unless it's ready to graph like these guys were, right? Up here it says the most challenging system will be using elimination method, or when using elimination method would be when you have to change both equations. So right here it's ready, or it's at least it's lined up. X is on top of x's, y is on top of y's, equal on top of equal, number on top of number. I want either the x's or the y's to cancel out. So the only way this 3 will cancel out with this value down here is if it were a negative 3, and I can't change 4 to a negative 3. I can't even change the 3 to become a positive 4x. I can't do that because 3 times 1 is 3, 3 times 2 is 6. I can't really change this to become a positive 4 to cancel with the negative 4. So what does that mean? I'm going to have to actually modify both equations, okay? I'm going to have to change this. You have to think of both numbers, 3 and 4. What number could both 3 and 4 become with multiplication? Obviously 3 could become 12 and negative 4 could become negative 12, and that would cancel out. So maybe that's our best option, to cancel out x's, but then again maybe canceling out y's is better. Let's think about this. Well, 6 and 7, yeah, it's not going to be that much better, because in order to change this, or in order to get this to cancel out with that, this would have to become a negative 42. This would have to become a positive 42. So you're talking about bigger numbers. You could multiply the whole top equation by 7 to make it a negative 42. You could multiply the whole bottom equation by positive 6 to make it a positive 42. Then they would cancel. So we could clearly see that canceling out the x's is better. And let's do that. Let's actually modify the top equation to get that positive 12x up there instead of 3x. So I'm going to multiply by 4. Let me make some space here. I'm going to multiply by 4. So let's go 4 times 3x, that is 12x. 4 times negative 6y, that's negative 24y. 4 times 9, that is 36. And then on the bottom equation, we're going to multiply that whole thing by 3. That way, the 3 times the negative 4 right there is negative 12x. Keep in mind, it has to be the opposite value. If this is 12x, this has to become negative 12x. That's the only way you're going to get the x's to eliminate. Let's continue distributing here. 3 times 7y, that's going to be a positive 21y. And last but not least, 3 times negative 16, that is negative 48. And of course, you could use a calculator on the test. Now it's ready to combine and eliminate. So the positive 12 and the negative 12x, they disappear, they eliminate. Negative 24y and positive 21y, that will leave you a negative 3y. Again, if you owe $24 and you only have $21 to pay, you still owe $3. Bring down the equal sign, and 36 take away 48 is negative 12. So that blue equation is a simple one-step equation. Let's solve it. Let's divide by negative 3, divide by negative 3. So your answer is y equals positive 4. So we have one answer. We need the other. Let's plug it into any original equation. These numbers look a little bigger than these, so I'm going to go with the smaller numbers here, the 3x minus 6y equals 9. Let me copy that over. As you could see, I wrote 3x minus 6y, but with parentheses equals 9. All I'm going to do now is take this 4 and plug it right in there. And from here, I'm just going to solve. So I'm going to do negative 6 times 4, that's negative 24. I'm going to write it as minus 24. So 3x minus 24 equals 9. Let's get rid of that minus 24 by adding 24 to both sides. So you're going to have 3x equals 9 plus 24 is 33. So my final step will be to divide by 3, and my answer will be x equals 11. So my answer, my answer as a coordinate to the system, which you have to write it as a coordinate, x and y value, the answer is 11, 4. So this is it's not the hardest, but it definitely requires more work than the previous system where all we had to do was multiply one equation by -1. Right here we actually had to multiply both equations. So that's the most amount of work you're going to do when solving a system with the elimination method. Now listen to this. Sometimes when solving systems of equations, we end up with special cases like no solution or infinitely many solutions. You could abbreviate if you want. If you're working on something and you end up with something impossible, like 0 equals, you know what, right there, it's a typo. Let's all do this. Like 0 equals 5, or it doesn't even have to be 0 equals a number. It could be something crazy like -6 equals 2. If you end up with something that's impossible, you say no solution, right? So going back to the notes here, if you end up with something impossible, like 0 equals 5 or like -6 equals 2, your answer is that there is no answer. You say no solution. Okay. So here's an example. Here's a system. And is this ready for graphing? Well, the top equation is, but not the bottom. Is it ready for elimination method? No. There is no x on top of x, y on top of y, equal on top of equal. So it's not arranged correctly for elimination method. You could rearrange it, but what method is the easiest for this one? I would say substitution, because it has y by itself. So y equals this variable expression 2x plus 6. So let's use substitution and let's plug that in to the other equation right on the y spot. So we need more space here. I'm going to rewrite this equation right here on the side. It's going to say 2x minus y, but of course I put parentheses instead of y because I'm going to substitute the variable expression in there, equals 2. So I'm plugging in the 2x plus 6. Now it's important that we always plug in with parentheses, because most of the time we will have something to distribute out here. Maybe a number. If it were a 3 right here, you'd 3 times 2, 3 times 6. But right here there's a minus sign, and we do have to distribute that minus sign. So distribute the minus sign to both terms. We're going to end up with a new equation, 2x minus 2x minus 6 equals 2. And of course we're going to solve by combining like terms after distribution. 2x, take away 2x, guess what happens here? This guy and this guy, they completely disappear. So what do we have left? Did I get lucky with this 6 minus 2? No, I already knew the answer. Yeah, -6 equals 2. That's impossible. So what do we say? We say no, as in no solution. And of course you could use this symbol. Okay, so this is a special case. Once again, it doesn't matter if you're substituting or if you're using elimination method. If you end up with something impossible, you say no solution. Okay. Over here. And sometimes you may be working on a system and you end up with something that's always true. That's when you say infinitely many solutions. So what do I mean by always true? If you end up with like 5 equals 5 or 0 equals 0, then you know that that's always true. You just say infinitely many solutions. So let's start working on this example, which is going to be infinitely many solutions. Let's say I wanted to cancel out, well, you need to decide, do you want to cancel out x's or do you want to cancel out y's? You probably think, well, the y's look a little easier. All I have to do is multiply this regular y by 6, and then it'll be able to cancel out with this -6. So let's do exactly that. Let's multiply the top equation by 6. And so let me distribute the 6 to each term. 6 times -2, that's -12 with an x. 6 times y, that's positive 6y. 6 times 3, that is 18. Now the bottom equation, we're going to leave it the same, which is 12x minus 6y equals -18. And now it's ready to combine and eliminate. Now, as you could see, this is kind of weird, don't freak out. The 6y that we wanted to cancel out with the -6y, it does cancel, it does eliminate. However, the -12x and the positive 12x, that also eliminates. So the equal sign comes down. What's left over on the left side, there's nothing left. So you put 0. But then again on this side, On the right side of the equal sign, it says 18 and negative 18. 18 take away 18 is also 0. So do we say no solution here? No way. This is always true. The only time we say no solution is when you end up with something impossible, like 0 equals 5 or like 2 equals 6. Right here it says 0 equals 0. That's true. That's always true. So the answer is IMS. What does that really mean? Infinitely many solutions. And yes, you can abbreviate on the test tomorrow, IMS. So what did we learn on this video? What did we learn today? That, yeah, elimination method is the best method. It's the fastest. However, if it's set up, ready to graph, you might as well graph. You don't have to do any math. You just graph it and you'll know the answer by finding the point of intersection. Or if it's ready to substitute, you might as well substitute. It's not that bad. Or you might end up with special cases. Now, what do I mean by special cases? If you end up with something impossible, like negative 6 equals 2, you say no solution. No solution. Or if you're working on something, whether it's substitution method or elimination method, and you end up with something that's always true, like 0 equals 0, then you say infinitely many solutions. Ladies and gentlemen, on the test, you will have several systems, and you will have to decide which method to use when solving the system. That's why on the notes it says deciding what method to use when solving the systems. Okay, guys, good luck. Study hard.